Hey guys, it's your pal Dave, notesandvolts.com, back with a new project. So if you don't know, I like to make music under the pseudonym Synthwave Dave on YouTube and also live shows as Notes and Volts on Twitch. If you haven't checked it out, please do. I'd love to have you. So during these shows, I play a lot of guitar, and if you play guitar, you know your hands are tied figuratively and literally. So I need some kind of foot keyboard that I can step on to add some extra notes. Now I went shopping for these foot keyboards and they are surprisingly expensive, so that is not happening. But luckily we can make our own, and if we did, it would probably look exactly like this because that's what this is. So here's my prototype for the foot keyboard. So I built a adorable little keyboard here, which of course will have to be bigger in the final version. We have the brains, a Teensy 4. I love using the Teensies for USB Midi because they just handle it so nicely. We have a nice little 3-digit LED display to give us all the information. And one of my patron supporters said, why don't you make 5-pin MIDI out as well? So I did. Here's a 5-pin MIDI jack. So you can have USB MIDI out, 5-pin MIDI out, or both if you're feeling crazy. So let's go over to the bench and I'll show you the circuit, how to program it, and how to build your own. But before we do that, I got to give a quick shout out to my friends at PCBWay who are sponsoring this video. PCBWay, your one-stop shop for circuit boards and manufacturing. PCBWay is a one-stop solution for all your circuit board and manufacturing needs. They can do circuit boards, multi-layer boards, aluminum boards, 3D printing, CNC machining, injection molding, and assembly. They can do it all. PCBWay is very maker-friendly with lots of services for small creators like myself. So check out PCBWay today and they can make your dream project a reality. Click the link in the video description to let them know that Dave sent you and you'll get yourself some free goodies. So thanks again to PCBWay. Okay, to start with, let's do a little demonstration and I can show you how this works. So first of all, we have to add power with the USB cable. So I'll plug it in. And we get the nice little startup screen, and right now it's telling me that I'm at middle C, or C0 as I called it here. Now if I want to use MIDI out with the 5-pin, I still have to just provide power with USB, so I could get a power brick or something and just run a USB cable in just for power and then take MIDI out of there. But I'm actually going to use the power and MIDI via USB for this demonstration. So if you notice in this window I have Ableton running, and if I go to the MIDI devices, you'll see NaV-KEY shows up in my list of devices, so I'll select that and I should be able to play this channel with the NaV-KEY. So basically here's my keyboard, here's low C, here's high C, and I've got all the notes in between. It is polyphonic, so if I want to play a chord, I could do that. Although I don't know how you do that with your feet. You'd have to be pretty acrobatic, but you can if you need to. So over here, these are our function buttons. So here we have our octave up and down button. So if I push the down button, you can see I'm down 1 octave. Or I could go down 2 octave. Ooh, I like that. I think you can go as far as 4 octaves down, which basically won't even be audible for this instrument. There you go. I can also go up an octave. And I can go all the way up to supersonic range. Yikes. All right. So that's basically how you'd expect it to work: octave up, octave down, and your keyboard. Now, I also wanted a hold mode, so I could just hit a key and then go do other things and the note would just keep ringing out. So that's what this button here does. This is the hold button. So when I press this, you can see the hold light comes on. Now, when I press a key, it will just keep going. And I can press another key, and it will replace that note. I could go down an octave. Very cool. And it will just keep going until I hit the hold button again and turn it off. So one thing to note is this is not velocity sensitive, but you can change the velocity, and this is how you do it. So if you hold the octave up button for 2 seconds, you're going to get into sensitivity mode. And basically the high C is 100% sensitivity, or the highest possible MIDI velocity value, which is 127. So if I hit that, it's going to say, okay, you're at 127, and then we go back to playing mode. Now, if I want to do less than full volume, I would go back to sensitivity mode, and I can hit any key. So basically, the low C is your gentlest or your lowest sensitivity, so that would be very quiet. That's like 10. You see the volume is very much reduced. Or I can go, say, halfway, 60. All right, but let's go back to full because I like it loud. There we go. And that's how you can adjust the global sensitivity of your device. Now we can also change the MIDI channel. So if I hit the octave down button and hold it, right now it's saying we're on channel 3. If I hit the hold button, I can cycle up the channels till I get to 16, and then I go back to 1. And once I get to where I want, let's go back to channel 1. Just hit either of these buttons to exit and store that value. And now I'm on MIDI channel 1. Now, one thing to note is that the MIDI channel and the velocity will be stored in permanent memory. So even when you power this off, those settings will be saved. So you don't have to reset it every time, which is very convenient. Now, there's one more little function, which is a panic mode. So sometimes when you're playing, something goes wrong, a note gets stuck, you don't know how to turn it off. That could be very embarrassing if you're on stage. So what you do is you hold the hold button down for 4 seconds and you'll enter panic mode. And there you go. So when you hit that, it's going to send an off command to every note on this channel, the channel that this is set to, and it should clear any stuck notes that are being held on that channel, and then we go back to normal, and hopefully your gig is saved. So there you go. That's how it works. Now let's take a look at the code and talk about how to upload it to your Teensy board. So the first thing you want to do is go to my Ko-Fi page and get the code. I'll put a link in the video description. When you get to my Ko-Fi page, you'll find the project NaV-KEY MIDI foot keyboard, and it's going to ask you how much you'd like to pay. Now, this code you can absolutely get for free. Put $0 and then just get now, and you will get it for free. Now, if you're a generous person and you want to give a little tip, you can type in the amount there, and it's very much appreciated, but absolutely optional. So go to Get Now, and you're going to get a file link where you can download a zip folder. So once you get the link, you can download the zip folder, unzip it, and you will get the following files. So you'll get the schematic. This is a PDF. That's the full schematic. You will get this hex file that we'll talk about in a minute, and the main program file, this .eno file. Now you have to ask yourself a very important question. Do you want to upload it the easy way, or do you want the hard way? So first of all, let's take a look at the easy way. So you probably want to use this if you don't care about the code, you just want to get the project working and you don't ever even want to look at the code. Let me show you an easy way to upload it. What you want to do is do a Google search for TY tools, TY tools, and you're going to find this GitHub page, the CoralMix TY tools GitHub page. Go to the page and find the releases area, and then just click on the latest version. If you scroll down here, you'll see some links. So if you're using a Mac, you want the OS X version. If you're using a Windows computer, get the Win64 zip file. Download the file, unzip it, and take a look inside. So when you open the folder, you're going to get the following files. You're looking for the TY uploader file, and just double click that. Then you're going to get this little pop-up window. And when you plug in your Teensy board, you'll see it appear in this little drop-down list here. Now mine is already renamed to NaV-KEY because I've already uploaded the code on this, but if it's a brand new Teensy, it will probably show up as Teensy 4.0 or something like that. So all you do is click the upload button, and you're going to browse to that NaV-KEY folder that you downloaded, and basically the only option you'll have is the hex file. So the hex file is a pre-compiled file that has everything you need in it. Just select it, click open, boom, just uploaded, you're ready to go. The file is now on your Teensy, and you're done. Now, if you're a little more adventurous and you want to actually see the code, and you want to maybe make some changes, we're going to look at the more advanced way to upload it. So go to the folder, find the navkey.eno file, and open that. The file will open up in your Arduino software, and you should have two tabs at the top. So you'll have the NaV-KEY and you'll have this name.c file. To program the Teensy with the Arduino software, you're going to need this little add-on program called Teensy Duino. If you go to pjrc.com, you can find it and read the instructions on how to add it to your Arduino software. Once you've added it, if you go to Tools and Board Types, you'll get this new category Teensy Duino, which will give you all the Teensy boards. Also a good tip, when you download and install Teensy Duino, it's going to ask you which libraries you want to install. Just click all of them and install them all. It will make your life a lot simpler. So when you upload it to your Teensy board, you're going to want to check the settings. So I put the upload settings right here. So you're going to want to go to Tools, to Board Type, and check Teensy 4.0. The USB type is Midi. This is very important. So go to USB type and select Midi. And finally, the CPU speed, you can just go to the top, 600 megahertz. Now to make this program compile, you're going to need some libraries. So you're going to need these libraries: Bounce2, LED Control, EEPROM, and Midi. Now if these are installed, if you go to your sketch menu and include library, you should see all the libraries that are installed in your software right now. So if those libraries are not there, if you go to sketch, include library, you can go to manage libraries and you can probably find them in there. Once you've got everything working, you can go to Tools, make sure that your port is the Teensy 4.0, and then just click Upload. The file will then compile and upload to your Teensy board. So now let's take a look at the circuit and the schematic, and I'll explain how it works and give you some building tips. Now, of course, this breadboard circuit is just a prototype, so obviously I'm not going to use these buttons for the final project. What I'm going to use are some of these heavy-duty foot switches. Those will be the switches I'm going to use. You want to make sure you get a momentary switch, not a latch-on, latch-off switch. So basically when you press it, it's on. When you release it, it's off. And that's exactly what these buds are doing, but they're far too flimsy and cheap, so we're not going to use those. Okay, so here is the NaV-KEY schematic sheet. And here's the actual breadboarded circuit, and I'll kind of explain how they relate to each other. So the main star of the show is this Teensy 4.0 microcontroller, and here it is on the board. Now you notice I have a symbol for a USB jack up here, but we're not going to worry about that. That's just if I want to fabricate a circuit board for this later. What I want you to do is picture a USB cable coming into this chip, and that USB cable is going to provide 5 volts and ground. So when the 5 volts comes into the chip, it's going to be made available on this pin here, this VIN pin. And I know it's kind of confusing because it's called VIN, but we're actually using it more like an output pin. Anything in our circuit that requires 5 volts, you can take it from this pin. Now the Teensy is a 3.3 volt device. So on the Teensy there's a regulator circuit that takes that 5 volts from the USB and regulates it down to 3.3 volts. That 3.3 volts powers the Teensy, but it can also be available on this pin, the 3.3 V pin. So anything that requires 3.3 volts, you can take it from that pin. So the numbers on the inside of the symbol here are the actual silkscreen numbers on the Teensy chip. So if you're looking to find a particular pin number, I would look at these inside numbers. Also notice there are 2 ground pins on our Teensy. They are internally connected, so you can use either or both. And anything that requires ground, this little triangle signal, and you'll find them all over, you're going to somehow connect it to one of those pins. So now let's take a look at this section here. These are the actual push button switches, as you can see on the prototype here. So I've labeled them as best I could. So C0 would be the low C, this guy here. C1 is the high C, this one here, and you can see all the other keys. This is D flat, this is D, E flat, E, right? Just like you would find on a piano keyboard. We also have our 3 function buttons. So we have octave up, which is this guy. We have octave down, which is this guy. And we have our hold button, which is this guy. Now you notice each button has one side tied to ground. So take one pin of your button, and what I've done on my breadboard here is I've taken this blue strip and I basically tied that to one of the ground pins on the Teensy, so that entire strip is ground. So there's a wire coming off each button going to that strip, so that's grounding that side of the button. Now on the other side, you notice we have these little flags. Now the reason we use these is because it would be very confusing if we drew lines all the way all over the place. It would be very messy, hard to follow. So all you have to do is take a look at a flag. So let's take this hold flag here, and then just find the corresponding flag on the Teensy and imagine there's a wire connecting those two. So if I look at my hold button, I've got one side to ground, the other side is going to a wire that is going to that hold pin, which is digital pin 7 on the Teensy. And just do the same with every button, run a wire to its corresponding pin. Okay, now let's take a look at our Midi out jack, and here it is here on the circuit. We have 2 47 ohm resistors. Now if you're familiar with Midi, you'll probably be wondering why we're not using 220 ohm resistors. Well, the 220 ohm resistors are for 5 volt Midi. We're actually using 3.3 volt Midi from our Teensy, so we have to bump those resistors down a bit to 47 ohms. So when you wire this up, just make sure you get the pin numbers right on your Midi jack. But you can see here we have a wire coming from our Teensy digital pin 1 through the 47 ohm resistor to pin 5 on our jack. And on the other side, we've got our 3.3 volt line. I've got a wire coming from that 3.3 volt pin through our 47 ohm resistor to pin 4 on our jack. And in the middle, on pin 2, we have it directly to the ground, one of our Teensy ground pins. And in Midi, we only use those 3 pins, even though it's a 5-pin jack. So leave these 2 pins unconnected, 1 and 3. In fact, anything you see with a little X on the schematic, that means it's not connected to anything. Just leave it alone. All right, the next chip we have is this guy here, the 74AHCT125. Quite a mouthful. This chip is called a quad buffer. So what we're using it for is to take the 3.3 volt signals from our Teensy and convert them into 5 volt signal, because our next chip actually runs on 5 volt logic and our Teensy runs on 3.3 volt logic. They won't want to talk to each other, so this buffer chip is going to translate those signals, keep everybody happy. You notice this chip is actually powered by 5 volts, so I would take it from my V-in pin and power the chip. We also have ground, so tie it to a ground pin. We have a little capacitor here. This is a 0.1 microfarad capacitor, and this is called a bypass capacitor, and it's just a good practice whenever you're using a chip to put a bypass capacitor across the power supply. So what you do is you put it as close as you can to the VCC or the 5 volt input pin on your chip, and then you connect the other side to ground. And what that will do is kind of store a little charge. So if for any reason the voltage sags in your circuit, this will provide a little boost to fill in that gap and keep your chip happy and stop it from glitching out. So we've got our data lines coming in to these pins here, and you can see the pin numbers on the lines here, and they're being buffered and they're being made available here and driving our next chip. Now this is a big important chip. This is the MAX 7219 LED driver chip. Now what this does is it takes 3 lines in and it converts it into the signals required to drive a 7-segment display. So here we have a 3-digit 7-segment display. This is called a common cathode display. You can also get common anode displays. You don't want that. You want the common cathode version. Now you can see this little package here. It has a pin for each of the segments. So we got A, B, C, D, E, F, G, and we have a decimal point. The decimal point is this little thing here. I'm not sure the exact order, but it's basically A, B, C, D, E, F, G. And that gives us our 7 segments. So basically we connect the correct segment on our chip to the corresponding segment on our display. Now we also have these digit pins. So basically the way the chip works, it's going to get a character sent from our microcontroller. It's going to decode that character and it's going to select one of these digits. So say it selects digit 0. It's going to select this one here. Then it's going to turn on the correct segments to light up our digit on this segment right here. And then once it's done that, it's going to go to digit 1, which would be this guy, change the segments as necessary, and then it will go to the next digit and so on. And you can see we can actually use 8 different digits. So you can drive an 8-segment display with this one chip. Now there's one more little thing, this LED here, and there it is. Now you'll notice I'm actually driving this LED from digit 3. So even though we don't have a digit 3 here, I'm making a fake digit 3 that only has the decimal point. So you can see I've got my decimal point line going into the LED and it's being driven from the digit 3 line. To power this chip, you notice we're using 5 volts, so take it from the 5 volt pin on the Teensy. We've got a bypass capacitor just like the other chip, and we've got a couple of ground pins. Now there's one extra thing, which is this 33K resistor, and that's running from the 5 volts into the I-set pin. Now what that does is it sets the overall current draw of the chip, and you can vary that resistor and make it brighter or dimmer. I did a lot of experimenting and I found the 33K to give you a nice even display that's not too bright, not too dim, just right. All right, so I hope that kind of explains how to read the schematic and how you would actually build this circuit. So there you go, guys, the DIY MIDI foot keyboard. I hope you enjoy the project. Before we go, let's give a quick shout out to my patrons on Patreon. Thanks, guys, for helping the channel out, and I'll see you all next time.